Okay, good morning. Today we're going to be talking about proving that a shape, a quadrilateral, is a parallelogram. If you see in the box here a summary of the ways that we can prove that a quadrilateral is a parallelogram. The first one is pretty straightforward. It's the converse of the definition. It says if you can prove both pairs of opposite sides are parallel, then the shape is a parallelogram. All right, that's this one right here. Um, The next one, if you can prove that both pairs of opposite sides are congruent, then it must be a parallelogram. Next, if you can prove that one angle is supplementary to both of its consecutive angles, then the shape must be a parallelogram. Next, if I can prove that both pairs of opposite sides are congruent, then it must be a parallelogram. Next is if I can prove that the diagonals bisect each other. Both diagonals have to bisect each other, then it's a parallelogram. And then lastly, and this is the one that's different from the properties and the definition that we talked about on Friday, if I can prove that only one pair of opposite sides are both congruent and parallel, then it must be a parallelogram. But you have to see tick marks and arrows in both the shape, the pair of sides there. All right, so taking a look at some of the ideas that we're looking at here, take a look at some of your exercises that you have for homework. In problems like number 8, you have what looks to be a parallelogram. If it's going to be a parallelogram, we know that the diagonals would bisect each other. So we could say that in this problem number 8, 2x equals 4, so x must equal 2, and y minus 1 would also have to equal 2y minus 7, so we would see that y would equal 6. I think that's pretty straightforward. In number 10, we can see that in this one, if it's going to be a parallelogram, we could assume that opposite sides are congruent, so AD and BC are both going to be congruent to each other. So 3x plus 1 must equal 6x minus 4. Solving, now we get 3x equals 5, so x would equal 5/3. In number 12, let's take a look at this number 12. If I were to take a look at opposite sides of a parallelogram being parallel, in number 12, hold on just one second. In number 12, we can see that since I have a parallelogram, that these alternate interior angles must also be congruent. So 4x minus 1 must equal x minus 38, and you could solve from there. Now look at the very bottom on problems 13, 14, 15. Is this enough evidence to show in number 13 that it's a parallelogram? Absolutely. Since we see that both pairs of opposite sides are congruent, then it must be a parallelogram. In fact, if you take a look, it says all sides are parallel or congruent. Later on this week, we'll take a look at what type of special parallelogram that will be. In number 14, I only have one pair of opposite sides, or one pair of diagonals being bisected. You'd have to have both pairs of opposite sides being bisected here, so this is not a parallelogram. And then lastly, in 15, it shows both pairs of opposite sides being, or both pairs of opposite angles being congruent. Therefore, it's a parallelogram. Take a look at some of these proofs. Take a look at number 20. I'm given that AB is congruent to CD and the BC is congruent to AADA. It's pretty straightforward to prove that's a parallelogram. All you have to do is write the givens, and then from there you can jump straight to ABCD as a parallelogram in the proof statement. And the reason would be both pairs of opposite sides are congruent. All right, and that pretty much sums up this lesson. It's just, again, pretty much the converse of what we did on Friday. I'll see you tomorrow.